All right, guys, we're gonna do Riemann sums. All right. So basically, this is where we get into the whole purpose or what integration is about. All right. The whole reason they first designed it is to figure out the area underneath a curve, because there is no good way to do that. Riemann sums was the first way to estimate it, and then next class is where we're gonna do actually find the area under that curve. Okay. So because of that, the very first thing we need to do is take a look at just some basic shapes. Now, you guys are only going to have to do rectangles, so keep it nice and easy for us. So the first one you should have all done, because this is from like grade 3. So if you can't do this one, I'm not going to lie to you. I may just fail you in the entire class. Because if you cannot do this, you are in the wrong class. So, don't you love those posters?
So sad.
But they're so true. No, you know, I used to have those posters. I had posters like that in Canada, and I always tell my AP students about them. And so a bunch of them went and got those made. They made their own versions of them and printed them for me.
That is so sad.
Yeah, it's so sad when you do those math errors. It's like a math sin. Anyways, okay. So like I said, who should we see if I'm failing in the entire class? Should we start with Elena? No? With Nicolas? All right, Nicolas. How do you find the area of a rectangle with width of 2 and height of 5? Oh, thank God. I was really scared I was going to have to, Now, there is no units, but technically, what would the units be if we had them? Because it's an area. Well, just squared, right? Like, it doesn't matter if they're centimeters or inches, or the point is just that we would have, like, we could even just write, like, units squared, just so we remember, right, it's an area. Now, the next one you should be able to do, but I realize it's written a little bit stranger. All I'm saying here is that I have 3 separate rectangles. I want the area of all of them together. So if they are all a width of 2, I could do like 2 times, what's the height of the first one? 3 plus 2 times height of the second. Plus 2 times 5. Now, if we look at this, another way that I could write that, if every single one of them is multiplied by the same width, I could also say 2 times 3 plus 4 plus 5. And I will get the exact same answer, right? So let's work them both out to show that. Martine, what's 2 times 3?
6.
Good. Jose, 2 times 4.
8.
Mares, 2 times 5. And then we put all them together, 24. Over here, we've got 2 times, and we do everything in the bracket first, right? 3 plus 4 plus 5 is 12. There we go. And 2 times 12 is 24. So you can see that no matter what, we're going to get the same number, right? We get the same area. And again, it would technically be units squared if we were worried about that. Okay.
Oh my God.
I know, right? Are you ready to get into it?
No.
Riemann sums. All right, so in calculus, the integral of fx dx is a function that represents the antiderivative, which we've already talked about for a couple classes. We often refer to this as an indefinite integral, meaning there's no bounds on it. Okay? Boys, I would listen up. Marco, Nicolas, Tomas. Okay. Just take one stack of them, like they're alternating. There you go. The result of the integral from a to b, fx dx, is a value of a region between 2 values. Okay, so in this case, we're only looking between a and b, where a and b are just values of x. Okay? Jose, listen up, man. So the Riemann sum is a way for us to estimate the area that's underneath that curve. And so the value of the integral from a to b for a graph function on a particular interval. I'll show you what that means in a second, because we're going to draw a bunch of pictures. You love those posters, I know. All right, so our first one then. We're going to approximate, we're using a left-hand Riemann sum using intervals of 3 units. I am aware that that probably doesn't mean a lot to you, so let's go ahead and go through it. So let's consider for a moment this function, which I graphed for you, f of x, and on the interval from 1 to 7, subdivide the area bounded by the graph of the function, whoops, weird, under the x-axis into the length of 3 units. So if I'm going from 1 to 7, right, and I want to do the left-hand Riemann sum. The left-hand part means that I'm going to place the upper left-hand vertex on the curve. So if I'm making a rectangle, this would be the left-hand side of it, if I'm extending this way, right? And it said to do it 3 units. So that would be 3 units. Do you agree that that would be a rectangle of 3 units wide where the left corner is on the graph?
Yes.
Good. So then I would need to do another one, this time starting from up here and going 3 over. Now, right off the bat, what do you see as a problem with the estimation? It goes outside the graph here and it misses this part here. And the idea or the hope is the parts that you overestimate are countered by the parts you underestimate. And we'll see how this changes based on how we decide to do this. Okay, so now we're going to calculate what the area of those rectangles are. Meaning that we could write the integral from a to b, which in our case is 1 to 7, of fx dx, which is this function. We can approximate, so we do the little, like, we either use this one or the one with the dot above it. I don't care which one you use. We can approximate it using these 2 rectangles. How wide are the rectangles? 3. So we put a 3, and then we need to get the heights. Now the height is going to be f of 1, which would be this height right here, and f of 3, because, or f of 4, sorry. Because those would be the heights on the left hand, because it's a left-hand Riemann sum. Okay? So then we can work out what that is. In order to do that, let's give ourselves a little bit more space. I need to find f of 1 and f of 4. What does it mean to find f of 1? If I have f of x, what do I need to do? I'm just going to plug in 1. That's all, right? So this is literally going to be like negative 1/3 times 1 squared, doesn't matter, plus 2 times 1, so plus 2, plus 5, right? If I put all that together, I get 7 minus 1/3.
6 and 2/3.
So, yeah, exactly. So we get 6 and 2/3, right? Which will be, why can't I think of what that is? 18, 20, 20/3? Should be 20/3. 1 plus 2 plus 5, 7. Yeah, I think that's right. Okay. And then I need to find f of 4 as well. Okay. And that's going to be, this one's a lot more difficult, right? So we might need our calculators because we need to put it in here, and it's going to be like negative 1/3 times 4 squared plus 2 times 4 plus 5. Okay? And on that one, we're going to need our calculator. So we're going to get, what, 16 times 1/3 plus 8 plus 5. And so we get 7 and 2/3, which is going to be 21 plus 2, 23. 23/3, I think. Math, frac, yeah, 23/3. Good. Man, my brain's not working this morning. Normally I do fraction operations better. All right, so that's going to be 3 times 20/3 plus 23/3. Okay? Which is the same as 3 times 43/3. And the reason I'm writing it that way is because what's going to happen to these 3 now? These 3's. Yeah, they just cancel out, right? Ciao. So the answer is just 43. Yeah? Excellent. Any questions about that? Does it make sense? So we're not saying that is the area, we're saying it's close to it. Okay?
Eso que no es todo, ese
Why the first raising everyone plus F4 and not plus F7?
Because we're doing it from the left-hand side. If it was the right-hand side, we would use f of 7 and f of 4, and no f of 1. Yeah, it has it because you put the corner of the rectangle either the left or the right hand side on the graph. And in this case, it's left. Right there, dear. Okay, so for our next one, what do you see that's different? What's up, man? I'm good. You?
Teacher,
Uh-huh.
can you help me with my grades of academic and theory because I cannot go to attend the
Can you come talk to me after this class? That window? Yeah. Okay. Okay. So guys, this time we're changing our width. What's our width this time? 1. So that means when we draw in our rectangles, they're going to only be a width of 1. And which side do we need to anchor on the graph? The left or the right? Guys, if you're looking at the answer key, I made some mistakes, so I wouldn't look at it. I'm just making sure. Right? So I got to mark the left, right? This is the left-hand Riemann sum again. Okay? So the left-hand one, and I go over 1. Then I go over 1 from 2. Over 1 from 3. And then from 4. From 5. And lastly, from 6. Because this time my rectangles are only a width of 1. And I'm going to write it the same kind of way. The integral from 1 to 7 of fx dx is approximately. Now, what's the width on all of them? So I could pull out the 1. Is it going to matter if I pull out a 1? No. But we'll still write it to show we know what we're doing. And then I need to find f of 1 plus f of 2 plus f of 3 plus f of 4 plus f of 5 plus f of 6. And I don't include 7, right? Because 7 is the right-hand side. It's not what we need, right? We're only doing the left-hand corners, so it's these ones here. Okay? Now, that just means I need to plug it in. So, for us, so these are just the heights, right? F of 1 means the height at 1. F of 2 means plug in 2 into the equation, right? And our equation was this. I'll write it up here again. It was negative 1/3 x squared plus 2x plus 5. That's the equation that we're plugging 1, 2, 3, 4, 5, 6 into. Takes quite a bit of work, so we need to use a calculator. This? I mean, it'll vary slightly based on your width and your heights, but yes. This one? Only for these examples. But there's no minus. Yeah, that's f of 6. It's plus. It didn't write properly. Sorry. So f of 1 we already did. What was f of 1 on the last page? 20/3, I think it was. Is that right? Yeah. So now we need to find f of 2, f of 3, we know f of 4, f of 5, f of 6. So we can use our calculators to do that, and we can do it fairly quickly. So what we can do is write in our graph. So we can say like negative, or our equation, negative 1/3 x, let's do a. It'll be easier here. To the power of 2 plus 2a plus 5. Then what you do is on decimals, you can say, give me a slider. I'm going to make that slider go from 0 to 10 with steps of 1. Now, the reason I'm doing that is because then I can easily just change this. And notice how I change it, and it automatically gives me whatever its value is up here. What? Are you using it?
No, I promise.
Hands up.
I'm not you. Mister is watching something on his computer.
Maxwell, close your laptop.
No, he's not.
Close your laptop because the answer key's wrong. I made some mistakes in it, so close it. I gotta fix it. Great.
No, Mister, make him close it.
Close it, Maxwell, or else I'll keep your computer too. Thank you. Okay, guys, if you notice in Desmos, you can set up something like this, where then you can quickly calculate it. So, rather than having to type it all out, I can say A is 2. Okay, there we go. So it was 7 2/3. 7 2/3 is what? 23/3. Then we need to find f of 3. So we go change our a value to 3. We get 8. We already did f of 4. It was also 23/3. F of 5, probably the same as f of 1 if we look at them, right? These are the same height. So it should be 20/3. And then we need to find f of 6. Let's confirm that our f of 5, yes it is, it's 20/3. Then we go to f of 6, it's 5. So this one's going to be plus 5. Okay. So then we just need to go through here and put all those together. So let's see, we got 20, 40, 60, 86/3. Plus 8 and 5 is 13. How do I put those together? I need to make this one over 3. So 86/3 plus 39/3 to give myself, what was that going to be? 95, 105, 125/3, I believe it is. Can somebody check that on their calculator, make sure we did that right?
Yeah, it's right. I checked.
Did you actually?
Yes.
Are you lying to me? I think you are. I'm going to check it just to make sure. Yeah, 125/3. Good. All right. So, guys, I want you to try this next one. What do you notice is different this time? How many units wide is it? 2, right? It's 2 wide, length of 2 units. So let's give that a try. I'll draw it out and I'm going to write it out, but you guys are going to try and do it on your own this time. So your rectangles should look like this. So once you're done, just look up and see if you've done it correctly. I can see that most of you are not actually trying it on your own. And if you prefer decimals, you can actually add this one as a decimal as well. Was anybody able to do it on your own?
Wait, the one, this one's in decimals.
This one is 41.6 repeating, the previous one. Was anybody able to do it? Or did you all cheat and look at it? Elena, you cheated, I know. I watched you cheat. Yeah. Almost as bad as Maras did. Maras, you're literally staring at the screen while you write right now. At least she looked up and down. Guys, when you got the you tries, I really want you to try and do them on your own. Just look up to check if you're doing it right. Okay? Because if you can't do them, this is going to be hard.
Let's do this in 2 classes, different classes, because this is very hard.
I know, but we don't have enough time for that. I don't think we have time. I'll check after we finish the right-hand ones. All right, so for our next ones, the only difference here is that, what did I do? Wait! You're not even writing. Well, the right-hand Riemann sum. So what do you think is going to be different from the left-hand one to the right-hand one? Yeah. Guys, nobody has an idea. If I change from left to right, what's the difference going to be? If left hand was put the left corner on, and the right hand would be not negative. No, not positive. Could be either. Guys, instead of putting the left hand corner on, I'm just going to make it so that the right hand corner is now on it. So we anchor the right hand corner of our rectangles now on the graph. So that means that when we are checking it, instead of this being f of 1 and f of 4, it's going to be f of 7 and f of 4, because it's the right-hand corner that's anchored on the graph. So f of 7 plus f of 4. Now we haven't found f of 7 yet, have we? But since we created this thing, I can change it to 7 and see that it's 2 2/3. Boys, you need to come get the notes. So if it's 2 2/3, what is that? 8/3. And we already did 4, I think it was 8 if I remember correctly. Right there, guys. Just get the whole thing, I think it's 3 pages. 3 or 4. Okay.
But 4 is 22.
Was it? Was 8? One, two, three. Ah, you're right. It's 23. Good thing we checked. Thank you. Yes, this one should have been 23/3. Then we can put them together. We're going to get 31/3. The 3's are going to cancel. And our answer is 31.
Wait, but no, but you don't have to put the relative.
I do. Because the width is 3. Yeah. Because the width is 3.
Wait,
Nicolas, do you know how to do this?
please forget you.
Then you should stop talking.
Show it again, please.
So for f of 7, we figured out already that it was 8/3. For f of 4, we found it to be 23/3. That's just plugging in 7 and 4 into the graph, or into the equation. And then we just simplified it. So 8 plus 23 is 31, and then 3 times 31/3 is just 31. If you look at this, do you think this is likely an underestimate or an overestimate?
Under.
Under, right? We have all of this stuff that we didn't include, and only this little extra piece that was extra. So this is definitely an underestimate. Okay, let's do the next one. This time we've got a length of 2 units. And again, it's right hand, so we start at the right, and we make them a width of 2. Now you can already see this one seems to be much more accurate, but still probably an under. There's a lot more stuff here that we're not including than the extra that we're including. So this is probably under again. And we set it up as the integral from 1 to 7 of our function. And because it's the right hand, we take all those right hand values for our height. So the width is 2. Our height is f of 7, f of 5, and f of 3. Guys, who's got that playing? Bean, is that you? Your phone. Turn it off, buddy. Okay. All right. So f of 7 we just did. I think that was 8/3. Yep. So that was 8/3. F of 5, I don't remember. F of 5 is 6 2/3. So that one was 20/3, I think.
20.
18 plus, yeah. And then f of 3,
That is 8. Yes.
that one is the one that's 8. So we could write it as 24/3 if it's 8, right? Better know how to do this or you guys are going to fail. 20, 40, 52/3. And then we multiply. And so that would be our simplified answer. Or we could also write that as 34.6 repeating. What?
Do you care if we write it one of?
No, I don't care if you use the decimal or the fraction. They're both right. All right. Now there's the one that you guys need to try. Since y'all not trying, Max, bring me your computer. Yep. So I saw most of you doing this, but not everybody. The right-hand corner is the one that needs to be anchored on the graph. I like to circle them to show me that that's what I'm doing, which now means that I'm integrating 1 to 7 of fx dx. And I want you guys to now come up with what this should be. Phone up there or else I'm going to take it. Raquel, put your phone up there or I'm going to take it. All right. So at this point, we figured out these. I'm hoping you worked them out. What is f of 7? 8/3, right? F of 6, I don't know. Have we done that one yet? I think we did. Ah, yes. 5, so 15/3. Good. So it's 5, or we can change that to 15/3. F of 5 was the 20/3. Ciao, man. Was F of 4 8? Was it? Okay. Ah, yeah. That's the one that's 23/3. Was 8, so 24/3. And then F of 2 is the same as F of 5? Ah, 23. I'm going to double check them. Now I'm nervous. So 4 was that. That was the 24, and that one is the 23. Okay, perfect. There we go. And then I put it all together. Look at that. Oh, let's see. That's 23, 43, 66, 70, 80, 90, 113 thirds. Or, if we rounded that to a decimal, we would get 37.6 repeating. Look at that. 37.6 repeating for 113 thirds. All right, before we go any further, what can we infer about the approximations as the width of our rectangles decreases? So if the width or length, however we want to call it, if we make it narrower, then what can we say about the accuracy? It's more accurate, right? We can see it like in this one, how little there is that's wasted or that's not included compared to say when we did this one, right? There was way more there. So the narrower the rectangles, the more accurate it is. So this is more accurate. Graphically, why is that? Well, we kind of just said it. It has to do with the fact that we have less, we call it, I don't know, waste or missed parts. Right? The stuff that is over, or not included that should have been, or that is included that shouldn't have been, there's less of it. So, what about if I take away the graph? It actually makes it easier. It makes it easier, trust me. This makes it way easier than the graph one. So let's take a look at it. Ready? So we've got a table of values here for our function f of x. We want to approximate from 0 to 25 using left-hand sum in 3 intervals. So our integration from 0 to 25 of fx dx can be approximated. Now the problem with the table is that your data isn't always perfectly spaced. So let's break it up into 3 intervals first. So I could go from 0 to 7, 7 to 15, 15 to 25. Is that roughly 3 equal intervals? Roughly. And I say roughly because what is the width from 0 to 7? And then if our height needs to come from the left, that would be this one. So times 15. The next one, though, from 7 to 15 is not 7 again. What is it? This time it's a width of 8. And so our width is 8, and the height on the left is -5. What's the width of our last interval here? From 15 to 25. The height is -2, you're right. The height's -2, for sure. What's the width, though, from 15 to 25? 10. So you can see that when you have a chart, sometimes you can't pull out that width like we did in the previous questions. Sometimes you can, sometimes you can't. You got to just kind of check and see. All right, so in our case here, 7 times 15 is going to be 105. 8 times -5 is -40. 10 times -2 is -20. And when I put all of that together, I'm going to get roughly 45. What does it mean if it's negative, do you think? Like, how would I have a negative area? What do you think might that mean? Kind of. That's a good guess, that it's outside the graph, and that is kind of correct. It might help if you think of physics, if any of you guys have taken physics. The direction, exactly. So negative just means it's underneath the x-axis. That's all it means, okay? So if you think of this particular graph here, right, all it means is that these heights are below the x-axis, and the positive heights are above. So like if you look at this particular graph, right, this is above, then it's below, then it's above. So it could simply be a quadratic, right? And if we were doing like our Riemann sums, we could have like a sum above, like this, right? And here it would be above as well. And then under here, those same things are now going to be below, right? So they would be negative. That's all it really means. Okay, so that's why I said think like physics. All right, we got one more, and then you guys get to do practice. One more, last one. Girl, you're going to have like 20 minutes. So from 4 to 20 this time. We're not going from 0 to 25. And we're going to do 4 intervals. So if I want 4 intervals, they've got to be smaller. Okay? Maxo? Too loud, buddy. Okay? The other part that's different is I'm doing the right-hand sum. So, for instance, when I look at this one, I want this as my height. What's the width from 15 to 20? Maxo, what's the width from 15 to 20? Maxo, you have such a girly voice. Yeah, you heard me. And the right-hand height would be 8. Maxo, what is the width from 12 to 15? Your voice came back. So glad to hear it. What is the width if we use the right? It's not 10. It's going to be this one here. Sorry, not the width, the height. I apologize. Right? We use the right-hand side for the width, so it's -2. Matas, what's the width from 7 to 12? It's 5. And then -5. No, it's not -5 because remember it's the right. So what's the height? -10. And then our last one here, let's go with Lucas. Lucas, what is it from 4 to 7? 3. And our height comes from the right-hand side. What's that? -5. So this one has got a whole bunch of stuff below the x-axis, basically, right? So let's simplify it. 5 times 8 is 40. 3 times 2 is -6, or 3 times -2, sorry. 5 times -10 is -50. 3 times -5 is -15. So this is going to be, let's see, -10, 25, 31. So what does that mean? It means that the area is 31 and it's below the x-axis. Okay? So this is area of 31 below the x-axis. Awesome.